Well, hello, what's up, mathematicians? Today we're going to be talking about squares and square roots. So I'm going to start by drawing a square here. And this square can be called a square because its sides measure, let's call them feet, 4 feet by 4 feet. All right, so each side you can see has 1, 2, 3, 4 units, and I'm calling them feet. Right, so each side is 4. And I want to know, what is the area of the square? And by area, I'm talking about this piece right here. The total area, say this was a rug on a floor. What is the total number of space the total amount of space it takes up? And you would have to think about this as finding how many of these smaller squares of 1 unit each are inside the larger area that it covers, right? And to do that with a figure involving 4 sides, you take length times width. Well, in this case, squares have the same, so we call it side times side. So 4 feet times 4 feet is 16 square feet, right? And you've known this for a long time, that 4 times 4 is 16. And you can count the number of squares inside this and see it's 16. There are 4 in this row. And another 4 in this row, that's 8. And another 4 in this row, that's 12. And another 4 in this row, and that's 16 altogether. So another way of writing this is 4 squared is 16. And some vocabulary for you. This 4 is called the base. And this 2 is called the exponent. The exponent simply will tell you how many times you're multiplying the base by itself. So in this case, we're multiplying 4 times 4, so we have 4 twice, and that is 16. 16 is said to be a perfect square, and perfect squares are numbers that have a whole number which multiplies by itself to produce that number, in this case 4 times 4. So is this true with other numbers? What about 2 times 2? Can we find, what is 2 times 2? So this is the side of 2, and this is the side of 2. 2 squared will be 4, right? And so 4 is the perfect square of 2. What about if you had something like 8 times 8? So 2, 4, 6, 8. That would go all the way up to here. And 2, 4. I think that's right. Yep, one more. Right, it would have to go all the way up to here, right? That's a pretty big square. Well, in order to find that, you would have to either count all those squares. I don't know if I did it right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. 8 times 8 is 64. So if you counted all of them, it would be 64. All right, let's go on to the next one. What other squares do you know? If you know your basic multiplication facts, you'll be able to generate quite a lot of them. 5 times 5, or 5 squared, is 25. And 6 times 6, or 6 squared, is 36. What about 10 times 10? 10 times 10 is 10 squared. It's going to be 100, right? These are all perfect squares, and you know all of them. You should know your multiplication tables quite high, at least 12. So from there, we would take these squares and figure out, is there anything we can do with them? Can we find the opposite? And the answer is absolutely yes, we can find the opposite. And it's called the square root. Okay, so the square root of 100 is 10. And the square root of 36 is 6. And the square root of 49 is 7. Okay? So this is an inverse relationship, and that means that if you can square 6, multiply it by itself, and get a whole number, 6 times 6 is 36, then you can also find the square root of 36 to be 6, which is the number that multiplies by itself. All right, some more vocabulary. This symbol right here is called a radical. Okay, and it means square root. So let's look at 36. There's a way to discover it if you don't know what it is. Let's say you forget that 6 times 6 is 36. Well, you can use prime factorization. 2 times 18 is 36. And 2 times 9 is 18, and 9 is 3 times 3. All right, so you have all these prime factors that you come to once you've done the prime factorization. And we say that the prime factorization of 36 is 2 times 2 times 3 times 3. And if you know that, then through the commutative property of multiplication, you can rearrange these numbers. So let's rearrange them to 2 times 3 times 2 times 3. And when I do that, I see that, lo and behold, we have a 6 times 6, right? And 6 times 6 is 36. So, that is a way to find it out if you don't know it or you don't remember it. Let's try another number. Let's try a slightly larger number. You should also know this fact. What is the square root of 144? Well, if you've memorized your multiplication tables, you know that it's 12. But let's check it out and make sure. Let's use a different method, the ladder method, to do it. Okay, so take out your prime factor of 2, and you're left with 72. Take out your another prime factor of 2, you're left with 36, and you can do it again. And you can do it again. And now you hit a number that is odd, and so you need to go to the next prime factor, which is 3, and you're left with a 3, and you're done because you're at a prime factor. All right. So how do I then express 144 as a product of its prime factor? So 144 is the same as 2 times 2 times 2 times 2 times 3 times 3, right? That got all of the numbers, all of the factors that we were able to pull out of 144. And I'm allowed to rearrange them. And so I'm going to rearrange them like this. 2 times 2 times 3 times 2 times 2 times 3. Okay? I know that 2 times 2 is 4, so it's 4 times 3 times 4 times 3, and I know that that is 12 times 12. And there I go. I've found the square root of 144 through prime factorization, because maybe I forgot it. I hope you wouldn't, but it happens sometimes. Okay. Let's try a slightly more difficult one. If we know, let's say we know that the square root of 81 is 9, all right? What is the square root of 8,100? Well, we can see very clearly that there's a relationship going on here between these numbers. We have 81 in two different place values. And it's important to note that these zeros here are a factor of 100. So what would be the square root of 8,100? Well, it is the same thing as asking yourself, what is the square root of 81 times 100? And notice that 100 is still under the radical sign here. we haven't taken 100 out of the radical sign. We still have to find the square root of 100 as well as the square root of 81. It's just that we know those square roots, right? We haven't memorized numbers maybe above 12 or so. Maybe if you're, very ambitious, above 20 or so. So when you come across a number like this, breaking it apart becomes very helpful. So we know that 81 is 9 times 9. And 100 is 10 times 10. Well, we can rearrange them like I just taught you. All right? And so we're actually looking at the square root of 90 times 90. All right? And so we can say that the square root of 8,100 is 90. Just like the square root of 81 is 9. Okay. Let's do one that's slightly more comfortable. Complicated. One that maybe you haven't seen before. What is the square root of 169? Well, it does happen to be 13. And if I ask you then, what is the square root of 16,900, how am I going to do that? Let's go ahead and think about it differently. The square root of 16,900 is the same as the square root of 169 times 100. And I know this is 13 times 13 times 10 times 10. Okay, everything under the radical. So the square root of 16,900 is going to be 130. And you can check that out. Try to multiply 130 times 130, and you should get 16,900. All right. How about this one? How about doing the opposite? If I tell you that 15 squared is 225, what is 150 squared? Well, 150 squared is the same as 15 squared times 10 squared, right? And 15 squared, we knew that was 225. And 10 squared is 100. So the answer is going to be 22,500. Right? This is all a matter of working with tens. Now I want to point out the relationship here. It's very important that you understand that these are multiplicative relationships. So 15 squared is the same as 3 squared times 5 squared. All right? So that would be 9 times 25, which is 225. So keep in mind that these are multiplicative relationships. You are multiplying here, and it's important to keep that in your head, that we're not talking about necessarily addition, but the multiplication. All right. I think that takes us to the end of what I had to do. This works either way. Let's try just one more. What about if I told you that the square of 41 squared is 1,681. What is the square of 410? Well, remember that we're talking about 41 squared times 10 squared. So that's going to be 1,681 times 100, which is going to give you 168,100. All right. I think that's enough examples. If you have questions, go ahead and email me, and we'll see you next time. Bye-bye.